Hello everyone, and in today's video I wanted to do a live stream on designing the PCB for the BHI160 of Bosch. I recently purchased the I.M.U. It's an accelerometer gyroscope 3-axis, and you control it using the I2C protocol. So this is the thing I got it from DigiKey. It's the BHI160B, and yeah, so I just wanted to do a video on how do you create, this is basically the actual chip, and how do you create a breakout board from here. So I thought it would be a nice video to create. The data sheet explains everything, so it's not too complicated. It's a pretty simple breakout board that one can create. So I have is a board fly that they have, and then they have a data sheet. So the data sheet tells you how to connect all the pins of the breakout if you want to create a breakout board. And I basically designed a simple schematic in Altium, and in here we have a couple of pull-up resistors for the I2C protocol. We have a couple of capacitors in here for the power for VDD and VDD-IO and voltage regulator. I get all of this information from the data sheet itself. It tells you what to connect, and actually over here, it tells you what's the value of your resistors, what the value of your capacitor is, and you just have to go around and build it. And based on that, I have connected all the pins, and it's going to be a 4-layer PCB. So we can look at the stack manager. So if I go to the design layer stack manager, we have 4 layers. So it'll be a top layer, then there'll be a ground, and we have another signal layer and VCC. So this is not a high-speed design per se, but because I wanted to make the form factor pretty small, and in order to trace all the routes, I needed more than 2 layers. There is a ground plane, and then there's one power plane. So this is the first layer. The second layer is basically a ground plane. Third layer is again signals. I've only connected one signal, and then the fourth layer is just the VCC polygon pore. So yeah, and what we have over here is something very simple. The whole idea is to have the board be able to, I want to mount it onto another board, so the main board would have the microcontroller, and then I could mount this onto the main board, something of that sort. So this is a small little breakout board. So the dimensions, so we can basically do a control or just gonna go and do the dimensions, and where is the measure, or is it control M? Yeah, so the dimensions of the board are, if I basically snap this and snap this, so the dimension is around 25 mm. It's a square board, so, and from here to somewhere around here, so it's 25 mm. So that's basically 2.5 centimeters. It's a very small board. So if I basically my ruler, so 2.5 centimeters would be basically, this is the size of the board, 2.5 centimeters by 2.5 centimeters is square, and what I have over here is rounded edges, so it's so you won't get hurt. Generally when they have sharp edges, it can be a little dangerous. So what I'm going to do right now is just basically finish it up, and then I'll send it for fabrication. So one of the thing is I don't want on the cell screen to print over some of these vias. It gets a little tricky when you're soldering at times, I guess. So this is C2, I can put this over here. This is C4, this is C4. Yeah, this is C3, I can put this over here. Just want to make sure P1. Yeah, this is R3, R4, and then I'm just gonna label the just gonna put text. Where is let's go to the properties. I'm gonna put a text over here and then label all the pins so that we know what the pins are. So G and D, that's ground. I'm just gonna put this as 0.75 as the size. This can be 0.175 as the width. So here we have here as, just gonna pin this. Ground. This is an SA GPIO. Okay, so I'm gonna move this VCC a little bit so that we don't need to. Tools, polygon port, report all. My cat is outside, it's asking for attention. I just want to finish this SA. Let's go GPI 07. Yeah, this is a big word, isn't it? I will basically make this quietly kind of smaller. 0.3. Oh, too small. 0.5. Yeah, something of that sort. Yeah, I can put the ground over here, so then I can have here as a GP. This is gonna be GPIO2. This is C2, that I can put C2. Oh no, you don't want to be too close. I can move slightly, maybe. And move this in here. Go to tracks. Just put this in here. Adjust everything so nothing is too close. VCC can definitely be oh, okay, wait a minute. Yeah. Yeah, okay, so track. Perfect. I want this. Okay, design, tools, polygon port, report all. Alright. Track. Okay, perfect. Okay, and GPIO2. I mean, the main thing is basically I need to put in this ground in VCC. I don't think I'll be using the GPIO pins for this breakout board. At least I wouldn't. Unless you're using some of their what is this? This is going to be INT, the interrupt. Yeah, and then I can just go to bottom overlay. So there's the top overlay and then there's a bottom overlay. The bottom overlay I can put this one, and I just want to basically change this to bottom overlay and put this as BHI1. Okay, so this will be in the bottom overlay. It's okay if they have this over here. Okay, then let me go to top overlay and put in a text. No, this is important. This is gonna be ASDA. I gotta get my cat in. Just give me a minute. All right, my cat is in. And I'm gonna put in this what's happening, ASCK. So these two, ASD and ASCK, I'm just gonna put them in the bottom layer because they have, if you want to connect other so if you look at the data sheet over here, this is the ASCK and ASDA if you want to connect to the Bosch external magnetometer or pressure sensor. So that's what the ASCK. So this is not connected to the host microcontroller, but these two are. So I'm gonna put a SDA over here and SCK over here. Okay, I think it looks fairly decent. Let me just save this. I'll be doing a yeah, I can put a little bit more space. R1, put R2 over here, put a track. Yeah, my cat needed to get out. Comes in, wants to make sure that I still like the cat, and then it's out. This is B2, just cleaning up some stuff. Okay, so let's do a tools and design rule check, and just do a design rule, run design rule check quickly. We have 5 errors, a silk to silk. Okay, that makes sense. Let's see where we are. Okay, fair enough. So this I need to move a little bit. Spacing helps for readability, so I don't. So all I'm gonna do right now is take this, take this, take this, take this, take this, and I'm just gonna say align to the align right, and then just move it all together. That should be it. Okay, and then let me go to tool, design rules check. Okay, and now I just have one more silk to silk. Let's see where this guy is. Oh, okay, perfect. And tools, design rule check, run design rules, and yeah, we have no errors. So if I go on and put a 3D, this is how it will look. So we have the SDA SDK, then we have some of the labeling on the board, and then we have on the other side of the board is where we have some of the oh, okay, this is not looking particularly good. Okay, I want to go over here, and we'll have to put mirror. Okay, anything that's in here we'll have to put mirror. And and then we go over here, and now it's looking kind of good. Yep. Yeah, the VRs are a little bigger than, but it's a very small board, so it should be fine. Let me do another design rule check. I'm just going to double check the schematic, and then we'll send for fabrication. There is no more errors. Let's look at the schematic to make sure that we have everything. SCASDA will have the 4.7 R1 and R2. R1 and R2 is 4.7k ohms. I just need to make sure the connections are, then we have one capacitor in here, then we have two other capacitors for the VDD/I/O and for the voltage regulator, pull-up resistors for the ASCK and ASDA, which is also an I2C. And then we have a couple of interrupts, and these are all reserved. So just to double check, yeah, it's only showing. So 1, 2, 3. Oh yeah, this is how you connect. Oh, they have this connected to ground. SAGPIO7. This might be the address for the. Guess you can control the address. Yeah, so, yeah, there you go. So the SPAGPIO7, if it's high, what do I have it in here? This is important. I have it floating. Device depending on logic level applied on to select the corresponding, keep the desired level for 10 nanoseconds. Default to application. GPI1 and GPI recommended piece required. Therefore, it's meant to be operated as a third application specific. Address and data transfer. Okay, so what do they have over here? In the they have a breakout board as well. Okay, so I might pin number 9. Pin number 9. Yeah, they just leave it floating over here. Yeah, they leave this floating. So this is also in the Bosch thing. I think is one of the shuttle board flyer. So they have a schematic of this board, and I'm just looking at how they connected the pin number 9. They have labeled it a little differently. I might just follow the data sheet and do what this should be done. And in the data sheet we have the schematic. All the registers. Where did I do the schematic? Table of content, pin, host interface. Okay, let me just go around here and see what the host interface. Okay. (16 and 17). So host interface. And if you have a sensor interface, yeah, okay, that's the ASIC. Got it. Where's it? I'm just gonna zoom this a little bit more. Packaging, environment. They don't have a do they have a schematic? No. Just gonna do this. Yeah, okay. Okay, so they have this connected to ground. I might just connect this to ground too. I don't want to leave this floating SAGPIO7. Actually, it doesn't matter, because if I have a breakout board and I want to select the address, and since I already have it as a pin, where is it? GPIO 7, I can connect this to VCC or ground, and so it's not particularly floating. Yeah, I'm good with this. Okay, so I'm just gonna do a design rule check to double check everything else, and I should be good to go. So just close this and click File, click Fabrication Output, and we just basically click Gerber files. Like it in millimeters, layers, just click all layers, drill drawings, picture advanced, just click OK. So it'll create a folder for me. I don't particularly need this. Can close this, the CAM file, and we also need to create file fabrication output, and then there's the NC drill files, units in millimeter, and then we click OK. Click OK, it'll create another, all the drill hole files. You don't have to save this. Perfect. And once I go into my folder, it should be in components. Oh, I'll show you what it's. Where is the I.M.U BH? Yeah. So the folder that it's created is project outputs, and then here's all the Gerber files and the rule check. I basically would just take all this. We don't need all this actually, we just need maybe this, and add to project breakout board, and then I will send it. It's created a RAR file, and from here I'll just basically send it for fabrication. Yeah, so that's it. So there's a breakout board. I'll be creating a couple of more breakout boards because I bought a couple of chips, I.M.Us, and just send them off for fabrication. So in the next couple of days I'll be doing some live streaming on creating some of these breakout boards. Alright, talk to you guys soon. Thank you.